Hi everyone, welcome to study sessions with Mo. I'm going to be talking about linked lists today. The last session we spoke about binary trees and we spoke about different things then, but this session is going to be different. We're going to be speaking about linked lists and I'm going to be sharing different resources, different things that you can use to learn, different things that you can use to gain mastery of linked lists. Also, I am also still growing. This is an accountability structure for me to keep growing, to keep studying. So you can join me if you want to. And yeah, thank you. So right now I'm going to start by sharing my screen, and I'm going to give you a breakdown of what we're going to be using. Let me see. So move this over here. I'm going to give you a breakdown of the resources. Today we're going to be using Geeks for Geeks. I might add some educative.io, but it was a bit hard to log in. So let's start again. Let's share our screen. Okay, so we're first going to be talking about what a linked list is, and then I'm going to also give us some resources from educative.io also. So what is a linked list? If you have any idea of what a linked list is, you can put it in the chat so that I can also get to learn from you too, or just an idea that you may have about linked lists. So let's look at the definition we have over here. So a linked list is a fundamental data structure in computer science. So it's used for easy insertion and deletion compared to arrays. So when we look at linked lists and arrays, I would like to actually show us a picture so we see the difference. So what I'm going to do is I'm going to draw. I'm going to draw a picture so you can see the major difference between the two of them. And then I'll share my screen after drawing. So I'm just going to show you different images and then we'll work into it. So let me present what I'm drawing to you. So today we're going to be more interactive in the sense that I would like you to also put what you learn in the chat too, or what you know about linked lists in the chat. So when we talk about a linked list, we can see a structure like this. So let's say that we have three boxes over here, right? And in linked lists, these boxes are known as nodes, right? And we want to link these boxes together. So we do it like this. Basically a data structure which allows for easy insertion and deletion. It has a head. This first node here is called a head, right, which is where everything begins. And then it has other nodes too that are joined to it. And there's also something I've not spoken about arrays before. I don't want to assume that everybody knows what an array is. So an array is basically a list. I would like to say it's a list, but I'm still going to use the definition from geeks to geeks. So in an array, we have different elements inside a we have different elements inside it, right? So let's say this is how an array is structured. So each box here is an element, and we can see the differences here already, right? Just with the drawing that I've made. Oh, okay. So now let's go back to our definition of linked lists. I hope you can see my screen. Okay. So a linked list is a fundamental data structure in computer science. So it's similar to arrays as you can see from the drawing I made, but it's not the same as arrays. Okay, so a linked list is a linear data structure that has a series of nodes, which I mentioned before, connected by pointers, right? So like I showed us before, if you look at here, this is a linked list, for example. We can call this node A. We can call this node B, and we can call this node C, right? These are all different nodes, and the first node is known as the head, okay? And they're all connected together. Sorry for all the ads. Geeks to Geeks has a lot of ads, except I pay for the paid version. But this is a nice free resource for people to use. So each node contains a data and a pointer reference, right? And unlike arrays, linked lists allow for easy insertion or removal of elements from nodes. Okay, so now see some differences between linked lists and arrays, and we're going to look at the different types of linked lists too, and we'll look at practical ways to solve problems with it. So when it comes to linked lists and arrays, right, he said something here that linked lists are non-contiguous while arrays are contiguous. Okay, let's break down what contiguous means. First of all, um, let's search Google for the meaning. So linked list shares a common border or touching. So as you can see in the drawing, right, this is our linked list. Let me label it. These are linked lists. And some things to notice from this already is that over here, right, each node is connected to each other through through the arrow, right? It's linked to each other. While in an array, it's not necessarily linked to each other, but it's side by side, right? And it is easy for us to, if anybody knows anything about arrays, you would remember that when it comes to retrieving information from arrays, you can easily say, oh, I want to get, let me label this. So we count things in an array starting from 0, right? So let's say this is 1, 2, these are the indexes in my array. And so let's say that I want to get a particular element inside this array, and let's say this is called R, right? I would simply just say R0, and it will print out what the value of this element is in the array. But as for linked list, it's not that straightforward in this sense, right? So we have our head. If I want to get the value here, I'll say head.next, right? And if I want to get C, I'll say head.next.next. So when it comes to these two data structures, they may seem similar, but they are not the same. So for linked lists, they are not side by side, while for arrays they are side by side, right? And for linked lists, so memory allocation, when it comes to us using memory, right? When it comes to us using memory, it is typically allocated one by one to individual elements. So when it comes to memory, right? If I want to calculate the amount of memory I use here, it is individually for each particular element, right? And if I want to add more, I can add more if I want to, right? For arrays, it calculates the whole array on its own. That's how it stores memory. So then insertion and deletion is inefficient in arrays, but insertion and deletion is efficient in linked lists. And this is why we say so. So I'm going to be drawing a lot here because I've seen that when it comes to understanding linked lists, it's better to draw, right? If you don't draw, sometimes you might be wondering what's going on. That happened to me so many times. So let me just bring this down a bit. Um, Okay, so in this linked list, right, let's say that I want to delete B from here, right? Let's say I want to delete B from here. One thing I can do is that I can assign this A to just connect to C directly, right? And disconnect this B from C. And I've removed it. I've already gotten rid of it, right? You see how easy that was? But when it comes to arrays, when it comes to deleting an element in an array, you have to think a lot before actually doing it because it's joined together. So it is what was the word that we learned today? It is contiguous, like we said before. So it's joined together, and so it might be a bit inefficient. Like if I just want to say, oh, array 1, I want to delete array 1, we might see that that space will still be there, but it will be empty. But as for linked list, it's easy when it comes to deleting elements from it. So I'm just going to put B back here because B has been a good boy. B for boy, right? B has been a good boy today. So another thing that we are going to be looking at is the different types of linked lists. Then we'll get into a problem, right? We can look into the operations of a linked list too. So when we have a singly linked list, right, let's load this up real quick. We have a singly linked list, we have a double linked list. So can anyone guess what kind of linked list this is? Singly or doubly? So it's a singly linked list, right? And the interesting thing about this is, how do I know? So each one is pointing to another node, right? But in a situation where we have it pointing back to each other. Oh, I wanted to put it in a different way, but it's not allowing me. In a situation where we have it pointing back to each other, I wanted to, it's possible to just draw a line. Okay, in a situation where the arrows are pointing back to each other, right? So, for example, it can go both ways. And let me see if I can just get an image for us. It's taking its time. My internet's slow today. But a doubly linked list, it points back to each other. So let me see if I can draw. Okay, I can just draw it. So for example, we can have it like this, right? You see how A is pointing to B. We also have a situation where B points back to A, right? And we even in B to C. Can I clean this? No. Let's delete this real quick. Okay, even in this area here, right, it points back to each other. So that's one thing about a linked list, right? So you can be pointing to one direction and pointing back. So in a way, they're all connected. While a circular linked list is like the name implies, it's circular, right? So right now we're just going to be getting into solving some practical questions, because I believe part of learning is also knowing how to solve questions too. And if you have experience with linked list, you can also put it in the chat so we can look at it together. If you have a question we'd like to solve together, like, it'd be really good so we could practice together. So I'm just going to share my screen right now. Present, share screen. Okay, so we're going to be solving the question. Okay, you can see my screen. We're going to be solving the question. Should we solve? Okay, I solved this before, but we can solve it again just to practice, right? Also, there's nothing wrong in remembering, learning, improving. So let me see. Are we going to? Let's try solving this one. Okay, so now, first of all, I've learned when solving questions about linked lists is to have a base case, right? So let's look at this question first. Given the head of a singly linked list, reverse the list and return the reversed list. So we have 1, 2, 3, 4, 5 here, and it wants us to reverse the list. I've solved this before, but I've learned that, like, if I don't remember data structures, I'll find it hard to use it, or like continually go back to it. I'll find it hard to remember. So over here we see how we just switched it out. One way we're going to be doing this is through keeping count of a previous pointer. Okay, a previous node, not a pointer. So over here, you see that I just switched it. So we're basically just switching it back. And then when I was just getting started, right, a naive approach I had was just to use dot reverse, right? But that won't likely work for linked lists, right? It can work for an array if you want to just use a built-in function in Python and just say, oh, reverse it for me, but it won't work for linked lists. So one thing we can do is that, first of all, we could have a base case that, oh, if we do not have a what are the particular things that could happen here? And we can see through the examples, right? If we don't have a head, what are we returning? We are returning nothing, basically, just an empty array. And so I'm going to start with that first. So if not head, actually, do you want to I'm going to write down thought process first before we get into solving it. So if we do not have head, and the implication of this is that we don't have any values in our linked list. So what are we going to do? We're going to just return an empty array, because nothing is going to be returned actually. So another thing that we can also think about is how we are going to solve this problem. And I'm going to draw my approach on another screen so that we can follow along together. So Let me stop sharing over here. And I'm going to share it on the other section. Mm, okay. Sorry for that sound. Okay, so over here we had different links list like, and it was secular. So it was secular. What we're going to do here is we're going to visualize the problem first of all. Okay, so everything in here is pointing to another value. So I'm just going to use this drawing thing and we're going to visualize it a bit. So we see that we will have values like this. So let's say that we have 1, 2, and 3 over here. Okay, so let's say that I want to reverse this linked list now. What do I do? So first of all, remember this first value in our array is called head, right? We know that we have a head simply because we see it, right? It's the first I said value in our array, sorry, the first node in our linked list is the head. So right now we're going to be switching it, right? If we say that, okay, I want everything to turn in reverse, so I want everything to go like this, what we are going to be doing is we're going to, first of all, I like setting my head to another variable name called current. So let's say that we call this current, right? Head is called current right now. And let's say that we have a value called previous, right? The value before head, which is previous. Some people like using a dummy node in this instance, right? Where previous is just like a dummy node that doesn't stand for anything. But I'm not going to use that for this. I'm just going to set previous to none. So let's say that previous right now is none. There's nothing there. Okay, previous right now is none. And so what we're going to be doing is that we're going to be saying while head, right, temporary is going to be equal to current.next. So this is going to be a variable name called temporary. And so we're going to be saying that while we have head, while we have this value, okay, set this temporary to the next value. So remember, I was explaining that. I hope I've not confused anybody. If you're confused, you can put it in the chat, because when I first heard about this, I was a bit confused. But let me tell you, it's not as hard as you think, right? Just think about it like a chain, like this is my chain that I have over here, right? Each one is connected to another one. So this is called dot next, right? This value is dot next. This value is dot next. So for example, I'm going to say temporary is going to be equal to the next value after this. Okay, the next value after this. So what's going to happen is that I'm now going to say that cur.next is equal to prev, right? So what I want to do is I want to be pointing the value backwards so that I can now switch everything backwards. Okay, so I'm going to code it out a bit, then I'll then explain it again. And it's not going to take a long time. So let me stop and then let's share the question again itself. Okay, so like I said before, we're going to set cur our current value to be the head, to be the head, to be the head. Then we are going to have a previous value, right? Because we want the node to point to our previous value. And then after that, what we're going to do is we are then going to have a temporary value. So the temporary value is going to be the value after our head. Okay, the temporary value is going to be the value after our head. So we're also going to have a temporary value. So we're going to set a temporary value that is set to the value after head. So like cur.next. Okay, after cur. Let's not call it head, after cur. Okay, so after that, we are going to say, what else should we say? So cur.next is then going to be equal to prev, because I want it to be pointing backwards. Okay, so I'm going to still draw this. Then prev is going to be equal to cur, and cur is going to be equal to temp. So what I'm doing is that I'm pointing everything backwards, and the while cur is going to be helping everything to loop. So I'm going to code it out, and I'm still going to draw it again so that we can understand. So if not hedge, I'm going to say return, right? We're not returning any value there. And then what I'm going to say, like I said before, right, we've gotten this base case. Now I'm going to delete that since I've gotten that. Now I'm going to set cur to be head. So I'm going to create a variable called current, and current is going to be set to head. So current is now this first head. Remember what I said before, that a head is the beginning of a, say head again. A head is the first node that we have. Let me increase my text a bit so that we can see better. So now the next thing I'm going to do is I'm going to be saying that prev is equal to none. So guess what prev is? Prev is the previous value before head, right? And I'm going to be saying while we have current, I'm going to say my temporary value. So I'm going to be creating a temporary value, which is going to be equal to cur.next. Right. So in a live situation, this is temporary, right? And I'm going to be saying my cur.next is equal to prev. So I'm going to be assigning this to the previous value. Okay. Then I'm going to be saying the previous value is equal to my current value, and then my current value is equal to temp. So what I'm trying to do is I'm trying to point everything to the other way. Okay, and this can get like mushy in your head if you're not careful. But that's why I really, really like drawing it, because drawing it helps us understand everything. So over here, we have assigned previous to now become our current head, and then the current is now going to be temp. So one way we can also try to understand this is by drawing it again. So I'm just going to stop sharing right now and then share the drawing itself. Then we're going to now understand, after we solve this problem, we're going to look at practical cases where linked lists are implemented so that we can identify when it's a linked list problem, when they want us, when like in an interview they want us to use linked lists or not. So so I just want to clean some of the things I did. Let me see. Let's just clean this a bit, make this neat again. Okay, so now I want you to remember what we did before, right? If you look at our code, we did, we stated that this is our previous value, right? So the value before, and this was our cur, and then this is our temp. Okay, this is our temp. So what we said was that cur was equal to head. So initially, head was here, right? And previous was set to none. Okay. Then after a while, we now said that cur.next, the next value after current, was now going to be equal to prev. So now it's pointing here. Okay. Cur.next was now going to be equal to prev. And then we now assign previous to be the head, the new head that we have, the new current, and then current was now equal to the temporary value. So we are basically pointing everything back here. Okay, we're basically pointing everything to face the other direction using our code. And you see how visualizing it makes it so much easier to like understand what's going on. Then what I'm going to do now is let's test out the results that I gave us initially. So let's run it. So this was accepted. Right. Then the next thing we're going to be looking at is practical ways where linked lists are used. The reason we're looking at this is because in an interview setting, right, I've learned when solving data structures that it's like solving math questions. In this sense, if you just rush straight to just solving a problem, in a math question, they can change it a bit, the teacher can change it a bit. So, what really helps you to gain mastery a lot of times, what from my experience, so because I'm also still learning, is you practicing, but practicing with a strong understanding of the fundamentals, because if you don't have that understanding, you might just be reading and not be able to replicate it when it comes to exam time, which happens in a lot of math exams, right? So to understand patterns, I usually use educative.io for that, and it's still loading, right? It's still loading, but I think I'll have a study session which is just for understanding patterns. I believe that would be useful, probably. So let's check it out together, shall we? Yeah, this live won't take less more than 30 minutes, surely. Should I be adding music to this? But I have to look for music that is not copyrighted. If not, they'll cut me out of YouTube. But yeah, I'm on YouTube, everyone. You can follow me there too. So let's look at understanding patterns in linked lists. So we've solved the question, reverse a linked list. We can also solve merge through sorted lists, right? Merge medium questions. You want to make sure that you understand easy questions, because a lot of times medium questions are a mixture of two easy questions, right? So let's look at this. I want to get us I want to get us let me see. Oh, you know what? I'm going to create a separate video for that and post it on my YouTube. That's what I'm going to do. But for now, thank you so much for coming. Um, Let me see if we can review some things before I head out. I wanted us to look at time complexities, but what I'm going to do is I'm going to do another live to talk about time complexities itself, because I'm also still trying to gain a mastery of that. But yeah, thank you for coming for study sessions with Mo. I hope you found this valuable, and also if you solve more links questions, you can post it, tag me, right? I want to be part of your learning journey the same way you're part of mine. So have a beautiful day, and yeah, bye.